All right, we're live back day one here, CAMX 2025. And joining me on this episode, I've got Russell Gentry. He is professor of architecture and civil engineering and a licensed structural engineer. He teaches graduate courses in building structures, computationally driven fabrication and construction. I got to say that real quick. That's a tongue twister. He's affiliated with the design and computing facility in the School of Architecture and Structural Engineering and Mechanics of Materials faculty in the School of Civil Engineering. Professor at Georgia Tech. He'll feel real comfortable here in the Hive, which is what we've
exactly.
It's now. It used to be formerly Park Place. Now it's the Hive. Mm-hmm. But being a Georgia Tech professor, is that an alma mater for you, or what did you?
It is.
Okay.
It is. I have 2 degrees from Georgia Tech.
Okay.
In addition to being a faculty member.
Oh, wonderful, wonderful. So we're going to be talking about the monogirder blade bridge, which is a unique design utilizing a retired GFRP wind turbine blade to support a 55-foot long pedestrian bridge. I want to bring this up real quick so people on the live streams can see it. This is pretty cool. I've pulled the website up. You can check this out over at, we'll put the link down at the bottom, research.georgiatech.edu. And so happy to have you on. Thanks for stopping by,
John.
Gary.
Thanks
Yeah, congratulations on your CAMX submission. And so if you would, before we begin talking about this project, let's talk about yourself. Tell us a little bit about your background.
So you probably know, Jonathan, that, we've been, I would say, like repurposing composite materials, bringing them into civil infrastructure for the last 30 years.
Right.
You've interviewed people who talk about repairs for seismic rehabilitation of structures, composite material rebar. So there's a lot of composite materials used in civil infrastructure, which is what I work in.
Sure.
So I worked for many, many years in developing new pultruded materials. I helped write the standards for composite material rebar. So there's a lot of these materials which we put into service 25, 30 years ago, which is now coming out of service.
Yeah.
And so the question is, what do we do with it? We know that in composite materials, the separation of the fibers and resins is kind of a struggle.
Yeah.
Right? Once we put them together, they're supposed to stay together. And now we got to get them apart if we're going to recycle them.
Right.
So the whole idea about my group, which is called ReWin, our group, which exists in the United States, Northern Ireland, and Republic of Ireland, is that we want to reuse the composite materials as is and not try and separate them and recycle them.
Yeah.
So
what inspired the idea? Obviously, I mean, that's a good segue. You talked about, recycling the material. You've got there's the challenge. We've had some guests already talking about, there is challenge. The technology's improving on separating and trying to get those virgin materials, but you're taking it as is and using it after life. So what inspired you to move in this direction?
I think there's a lot of people in civil infrastructure who are looking at this because we consume such vast quantities of materials in buildings and bridges and highways.
Yeah.
So in just looking at life cycle assessment, I didn't grew up as a structural engineer, always thinking about creating things, not recreating things. And so I think in a way, you might say we're inspired by wood, because wood is inherently a second life material because its first life was as a tree. So every piece of wood that we use structurally is then reused.
Yeah.
So I think that might be our inspiration.
So why the blade, the wind blade?
Well, it's the largest piece of composites made. I mean, except for maybe a aircraft frame.
Right.
And so I think that and also, we started 10 years ago when the press wasn't quite as hot on this topic.
Yeah.
But I think early work that we did in terms of repurposing, where we were shredding the material, trying to put it in concrete, cut it up, and put it into other forms of composites as filler, really showed that the properties weren't that great when you break it down and reuse it. So the kind of structural reuse idea was born from that.
Yeah. So typically, what I was asking this question earlier, end of life on a blade is what, about 20 years roughly?
So it really depends. I think 15 to 20 years is the expected end of life.
Sure.
There's some in the Nordic countries and Germany now, which are 35 years old.
Okay.
So it really depends on the fatigue life or the fatigue history of a given blade in the current wind site. Some of them are lasting longer than we thought.
Okay.
But most of the blades we're repurposing here in the United States have reached the end of their economic life. And because of repowering, they're actually coming out of service 10 to 15 years, old, as opposed to that 20 or 25.
Right. Yeah. So we're looking at a picture. Where did this particular blade come from?
So this is a Siemens Gamesa, SGRE, Siemens Gamesa Renewable Energy B45.
Okay.
So this was 45 meters long originally. And our friends at Siemens Gamesa sent us 2 of these sections.
Okay.
They cut these for us and sent them from Colorado.
Wow.
So that's where they were deployed. And what you can see, obviously, is the root and the tip are gone.
Yeah.
Because that makes shipping a lot less expensive.
Right.
So we've deployed approximately, let's say, 1/3 to 1/2 of the blade on this bridge.
Wow. And where is this? This is located in the Atlanta.
So Georgia Tech is in Atlanta, and the client, Beaverbrook Park, where we built this bridge, is luckily only 6 miles from our campus.
Right. That's amazing. You need to come by and see that.
Yes, it's really gorgeous. I mean, the kids love it. They don't know what it is until they kind of, get up next to it.
What was involved in the collaboration on this, making this work from your standpoint? What had to happen?
Well, I think what we're trying to rationalize is the economics of getting hold of the blades. I mean, that this was actually a donation from Siemens Gamesa, including the transportation. So that's a huge benefit for our team.
Sure.
And then the kind of engineering analysis, refabrication, and because this is in the public domain, life safety is critical. This is both a prototype and a real working bridge. People walk across it every day. So,
it's amazing.
So you have to imagine that there's quite a bit of testing and other work that we did to make sure that
I'm sure
it works.
It's been a work in progress. When did this?
We got this first opportunity about 2 years ago.
Okay.
We built 2 and are on our 3rd smaller bridge in the Republic of Ireland.
Okay.
And these are from, say, 17-meter early Vestas blades, whereas this is from a 45-meter blade, so 3 times as long. So this is our first opportunity in North America to build one of these blade bridges. So
I was trying to play the video just to showcase, but maybe there may be some issues streaming a video within a video.
yes.
I don't know. So,
not my technology.
Exactly. Well, Russell, thank you so much. I know you're here for today. You've got to get back because you got some students to. You've still got to get some teaching responsibilities to handle back at Tech. But I appreciate you dropping by, and congratulations on
Thanks,
this.
Jonathan.
Yeah.
Thank you for having me.
Yeah,
it's a
thank
pleasure.
you. Yeah, thank you for your time.